Hi, so hope you remember me. The first three videos I have put the simple concept of VLSI design, which are relevant to the first three units. So from the each unit I have put one topic. So hope you might have seen that. Let us have the continuation with the fourth unit, that is FPGA. Today this is the topic we are going to see. The FPGA is a very familiar topic since it is a hardware substance. This has to be explained in very clear and crystal manner, and this is also an important topic as far as the VLSI design is considered. From the introduction itself, I have told you that the VLSI design is going to be implemented by the two kits. The first one is the FPGA kit, and the another one is the ASIC. The FPGA is about the field programmable gate array, and whereas the ASIC, that is ASIC, is about the application specific integrated circuit. These both are the hardware kit. The applications that are programmed under the VLSI design are implemented in these two kits, two hardwares. Right. So now let's going in deep about the FPGA, field programmable gate arrays. What is this field programmable gate array means? Actually, in the olden days, the memory is a substance which is the basic thing for the FPGA. So hope you all know about the memory devices. Especially in real-time applications, the memories are playing a major role in most of the gadgets. For example, if you take an electronic watch, the memory is there. Mobile phone, the memory is there. Even personal computer, laptop. So whatever the things where the data are being stored is having the memory. We just say it as a memory, but as far as the memory is concerned, it would have been different types and different categories. So you know that the memories are having two types. They are RAM and ROM, that everyone is knowing about it, and also the working conditions of RAM, and also the function of the ROM is also maybe known by everyone. The another thing is that coming under the memory is that programmable logic devices. So what is this programmable logic devices? So in the digital electronics itself, we might have seen that the devices that where we can able to program. So those devices are said to be as the programmable logic devices, which is having two types. Again, programmable array logic and programmable logic array. So both the programmable logic array and programmable array logic are consisting of AND or logic implementation. But the updated version of this PLD is the FPGA. Even though the FPGA is one of the type of the ASIC, it is have certain features which are entirely different to that of the ASIC design. Right. Now coming to the FPGA. FPGAs are integrated circuits. So integrated circuit in the sense these all are the ICs that can be reconfigured after manufacturing to perform specific functions. So I'm going to design a FPGA for adding two numbers. Now this is my concept. I want to do some simulation. I have obtained the simulation result. Now I want to do some implementation with the hardware. I prefer the FPGA kit for implementing this uh, performance of addition of two data. Okay. Now I have completed the process and I have succeeded. I got the output. Just imagine that in the next thing I want to do some multiplication, which is entirely different to that of the addition. Again, I am writing the program for that. I getting simulation output. Now the same thing I am going to implement it over the implementation FPGA. Again, I got the output in the through the hardware material. So now my project has been completed. Similarly, in order to perform the some other operations, that is, it may be a logical operation, that is a combination logic or sequential logic, ALU, like that. I can do any kind of operations over this here integrated circuit. Whenever I am doing the project in the integrated circuit, this particular FPGA, I am going to erase once the project is completed. I am not going to have it for lifelong. Once the added process is completed, I am going to delete the project and it will be replaced by the multiplication. And as soon as the multiplication is completed, I would have deleted it and it would be replaced by the shift register or counter. So, like that, the things are being done repeatedly in a particular kit are said to be as a field programmable gate array. They are programmable logic device and are often used in consumer products. They are commonly used in the following industries. So, what are the industries where the FPGAs are commonly used? These are playing a major role, as I told in the beginning itself. It has not been used in the telecommunications, automotive, and aerospace. So, these are the three things where the FPGAs are being used. What are the features of FPGA? Next one is the FPGA features. So FPGA can be programmed to suit different purposes even after the chip has been released from the manufacturer. Once the chip is released from the manufacturer, we can also use it for the reprogrammable structure. This allows for feature upgrades and bug fixes to the perform install. Versatile, FPGAs are highly valued for their combinations of high performance and extreme versatility. They can also be used to perform a wide range of functions from a simple logic gates to complex functions. Most of the simple logic gates and the complex gate functions have been designed by using this field programmable gate array integrated circuits. Then the third benefit or the third feature that this FPGA are having is that it can handle parallel inputs simultaneously, where the microcontrollers can only read one line of a code at a time. So at a particular time, if you take the microcontroller, it will read only one line, whereas the FPGA processing is done in parallel, which is more and more faster than the other logic devices. Then faster than CPU, that's the continuation. Faster FPGAs and the GPU processors can execute an AI algorithm much more quickly than the CPU. So look about this. This is an FPGA diagram. So and the next one is the FPGA real-time diagram. So these are the two diagrams that we are going to see and compare now. Combination logic circuit. Uh, Here the input and output blocks are mentioned. The same way the input blocks are given in the form of switches and output is represented in the form of LED. Then logical blocks that is not defined in the particular circuit diagram. The next one is about the programmable interconnect. Yes. So the final thing is the FPGA kit. Hope you might have seen in your college or anywhere, and in the industry, these kits are playing a major role. Getting job for VLSI reason is a tremendous challenging thing nowadays. So try to understand the topic and give your explanation. Thank you.